Hello children, I am here with another part of the chapter 6 electrolysis, and in this today's video we will discuss electroplating of iron with nickel. Okay, today we will discuss the electroplating of iron with nickel. See children, in this electrolysis we will take two electrode, one is positive and one is negative. Negative is cathode and positive is anode. So negative is that electrode on which we want electroplating. So article to be plated is taken as cathode. Here we want electroplating of iron, so you will take anode as iron. Okay, iron will be the cathode, and the metal to be plated is taken as anode. So here we want plating with nickel, so you will write nickel over here with anode. Okay, so anode is made up of nickel, cathode is made up of iron, and the electrolyte we will take in which this nickel must be present. So here electrolyte is nickel sulfate solution. Okay, this is nickel sulfate solution. With this nickel sulfate solution, we will add a very small amount of dilute sulfuric acid to increase its ionization. Okay, so dilute sulfuric acid is also added few drops to increase the formation of ions. So the electrolyte breaks into NiSO4 breaks into Ni2 plus and SO4 2 minus ion. At the same time, water also get dissociated into H plus and OH minus ions. Now see how electrolysis takes place here. In this electrolyte, the solution contain Ni2 plus and other ions also. These ions are also there. But due to the nature of electrode, only Ni2 plus will get deposited towards cathode, because Ni2 plus is plus ion. It will move towards minus electrode and it will gain electron from here, from cathode, and it will get deposited as nickel metal. Okay, at the same time this anode breaks down and form Ni2 plus ion, leaving behind 2 electron over here. Okay, so this nickel breaks down, pure nickel breaks down into Ni2 plus ion, leaving behind this 2 electron, and this 2 electron will move towards cathode. Now what is happening? The concentration of Ni2 plus remains same in this electrolyte. Okay, because whatever Ni2 plus is getting deposited as at cathode, the same amount of nickel comes from anode and break down into Ni2 plus ion. So this will be the total full process of electroplating. So the reaction at cathode will be Ni2 plus, which is getting towards cathode. Ni2 plus is getting towards cathode, and 2 plus means it has 2 electron less to form a neutral atom. So it will gain 2 electrons at cathode and form Ni only. Okay, and nickel metal will form. And at cathode what is happening? Pure nickel is breaking down into its ion, leaving behind 2 electrons. Okay, or you can write this equation like this also. Ni gives Ni2 plus, this plus will come to the right hand side and it will be minus, will turn into plus 2 electrons. So this is the reaction at cathode or anode. Or you can write NCR. R is reduction, or you can write reduction reaction is this, and anode is PaO is oxidation. Okay, positive anode oxidation, negative cathode reduction. So this is reduction and oxidation reaction respectively. So now what is the observation part? You will notice that there is thinning of anode. Anode will get thinner because it is getting broken down into Ni2 plus ion. The thickness of cathode increases because nickel is getting deposited over cathode. The third one is the color of electrolyte remains same because the number of nickel ion or concentration of nickel ions is not getting affected by this deposition at cathode. So these are the observation. Now spectator ions. The ions which will not get discharged at any electrode will be SO4 2 minus, H plus and OH minus ion. So these three are spectator ions. These are not getting discharged at any electrode. Now these are the question which is based on above electrolysis. Why electroplating of iron is done? This is to prevent it from rusting. Prevent it from rusting or corrosion. To prevent it from rust. Oxidation and reduction reaction, you will write the reaction taking place at cathode is Ni2 plus 2 electron gives Ni, and anode it is Ni gives Ni2 plus and 2 electrons. So this is oxidation reduction reaction. Why H plus and SO4 2 minus OH minus ions are not getting discharged? This you will write due to nature of electrode. Due to nature of electrode. Okay, because electrode is made up of nickel and in the electrolyte also it is nickel. So when these conditions are there, then no other ion will get discharged at any electrode. Okay, now next question is iron is made at cathode, nickel is taken as anode. What do you observe? Just 3 observation you will write. So these are the question which is based on this electrolysis process. Now next we will do electro-refining of copper. But before that we have to understand what is electro-refining. It is electrolytical refining also. It is a process by which metal having impurities are purified by passing electric current taken as DC current to give pure metal. Okay, so the metal that we have collected in or we have got during the process of metallurgy, that impure metal will get purified by this electro-refining or electrolytic refining process. For electro-refining of copper, this is the apparatus arrangement in which we have taken anode as impure copper. That means the extracted copper from metallurgy is taken as impure copper as anode, and the pure form, a thin strip of pure copper, is taken as cathode. Okay, so this is the thickest part of impure copper, and very thin sheet or wire of pure copper is taken. Now we want to purify copper, so we have to take the electrolyte in which copper must be present. So we have taken copper sulfate in the solution form. Now what will happen during this process? When current is passing through this arrangement, this copper sulfate break down into Cu2 plus and SO4 2 minus ion, Cu2 plus and SO4 2 minus ion, and water breaks down into H plus and OH minus ion. Again, when this Cu2 plus ion has formed by passing this current, these ions will start moving towards negative electrode because positive and negative attract each other. So 2 plus ion will move towards minus electrode. At the same time, impure copper breaks down into Cu2 plus ion and maintain the concentration of copper in the electrolyte. So after some time you will observe that the thickness of anode is decreasing due to this breaking of copper, and the thickness of pure copper is increasing. In the beginning you will notice that anode is thicker and copper is very thin, cathode is very thin, and at the end of the reaction you will notice that anode is very thin and cathode is getting thicker and thicker. So why we do this electro-refining of copper? Because when we need copper wires, that must be in its purest form. If there is a very small amount of impurity in that copper, then its conduction will get affected. Its conductivity will get decreased. So that's why we need pure copper for the transmission of electric current. So at cathode you will see that what ion is coming? Cu2 plus. 2 plus means how many electron less? 2 electron less. So it will gain 2 electron at cathode and it will deposited as Cu. Now at anode, what is happening? Anode itself is breaking down. It is itself is breaking down into its ion. So it is forming Cu2 plus ion, leaving behind 2 electrons. Or you can write Cu gives Cu2 plus and 2 electrons. So this is at cathode and anode reaction. Cathode is reduction and anode is oxidation. One thing you will notice over here, during this process some impurities are also there in this impure copper. So some of these impurities get dissolved in the electrolyte, which are soluble in the electrolyte, and some of the impurities get deposited over here as anode mud. This is called anode mud. It is made up of that substance which are not soluble in the electrolyte. Now the observation part is that in the beginning of reaction, anode is thicker than cathode because anode is impure and cathode is pure strip of copper. Second is, on completion of reaction, you will notice that cathode is getting thicker and anode is getting thinner. Okay, it is getting thin and cathode is getting thicker, and finally you will see that it is vanished. Anode is vanished. In the electrolyte, the blue color of the solution remains same. Third is, blue solution of electrolyte remains same throughout because the concentration of copper ion remains same. Fourth one is, some insoluble solid is collected at the bottom of anode. These are the impurities which is not getting dissolved and it is just collected at the bottom of anode, which is known as anode mud. And these impurities are mostly silver and gold. Now some questions arises here based on this electro-refining of copper. First thing is, what do you observe during electrolytic refining of copper? Second is reaction at each electrode, that we have already done. What is anode mud? It is the insoluble impurities, mostly silver and gold. Why do we refine copper? Because pure copper can conduct more effectively. If there is very small amount of impurity in it, then its conducting get affected. It will not conduct that much good. So this is the electrolytic refining of copper. This chapter is done now. Thank you, children.